welcome back to Algebra. So, we were just talking about algebraic equations. Now, tell me, what do algebraic equations actually mean? Well, they can mean many things. One thing is, well, finding a missing number. But another thing about it is if you were given the equation with two variables, let's say I gave you the equation x plus, actually let's not even do that. Let's just make it y is equal to, whoopsies, y is equal to x. Let's say you're given this equation. Well, tell me, what does this mean? Well, it's for graphing purposes. Basically what this means is that for every x there is a y. This is a function. Y is a function of x. So y, whoops, still in that mode. So y can also be written as f of x. It's another way of writing y, because y is just a function of x. So, if you're given y is equal to x, that means whatever x value I give you in an equation, in a graph. So say I give you the x value, x is equal to 2. Let's just make this 1, okay? Just to make it a little easier. So x is equal to 1. So what is y? Well, y is equal to x, and x is right now equal to 1, so y is equal to 1, correct? So let's make this 1. This is your y axis, and this is your x axis. See, whatever value you have for x will be on the x axis, but when you plug it in to the function, your output is y, which will be described by the y-axis. So let's say I gave you x is equal to, let's say, 2. So what's y? Well, when x is equal to 2, y is equal to x. So by the transitive property, y is equal to 2. Y is equal to 2. So let's make these points. Here's one point, here's another point. But it's not limited to just this quadrant of the coordinate system. But that's what this is called, a quadrant. It can also go into this quadrant here. When x is equal to what? On a number line? -1. Y will be equal to what? -1. So this point is right here, because the point is always where the two lines intersect. See that? And when x is equal to -2, then y is equal to -2. So here, there you go. This portion of the y-axis, just right here, that's the positive y-axis. And this portion right here is called the negative y-axis. Using the same concept, right here, this is called the positive x-axis. And what is this portion called? Right here? The negative y-axis, a negative x-axis, correct? So, what if x is equal to 0? Well, the point of intersection of the x and y-axis is the point 0, 0. So when x is equal to 0 and y is also equal to 0. So when x is equal to 0, y is equal to 0. So this is that point. Now, what do these dots mean? Well, it doesn't mean anything really until you add a line. This line represents the dots, connecting the dots. It covers every possible x value and the resulting y value. So if x was equal to, oh, I didn't mention it, but if x was equal to, let's say, 0.5, let's say 0.5, then y right here will be 0.5, and so on. Understood? So a line will cover every point. So in this example, the line is sloping upwards. So it's going this way. Correct? It's going this way. There. So that's what the line would look like. And it even continues further and further, because it doesn't just stop there. Because this coordinate system can go very far. It goes infinite. It goes up to infinite. So it's continuous. It's a continuous function. So this means that no matter what, x will be equal to y. Got it? So using that, if I gave you x is equal to 4, what is y equal to? Let's see. Well, if y is equal to x, and x is equal to 4, using the transfer property, y is equal to 4. So 4, and it meets at this point, about, and this meets at this point right here, about, right? See, I'm not to scale right now, but if you were to go to scale, it would be equal. So that's what this line represents. Now, there can also be another line which goes negative, or it'll go down this way, basically. Let me show you. Let's get our coordinate system out. So here's 1, here's your y-axis, and here's your x-axis. Okay? So if I gave you the equation y is equal to negative x, this is another way of writing y is equal to what? Negative 1 times x. Got it? This is another way of saying y is equal to negative 1 times x. So whenever you're given an x, let's say your x is equal to 1, then plug it in. Y is equal to negative 1 times 1. Negative 1 times 1 is equal to negative 1. So this point right here is negative 1. So negative 1. So this point is 1 comma negative 1. When x is equal to 2, well, when x is equal to 2, 2 times negative 1 will give you y, which means y is equal to negative 2. So where's negative 2? Negative 2 is about there. So it's about this point right here. Similarly, when x is equal to 0, what's y? Well, y is equal to negative 1 times whatever the x value is. So if x is equal to 0, then negative 1 times 0 is equal to 0, because anything multiplied by 0 is equal to 0. So 0 comma 0 is another point right here. Now, if x was equal to what? Whoops, let me write that in right here. So let's say x was equal to negative 1, then what's y equal to? Well, negative 1 times negative 1 is equal to what? Positive 1. Because a negative times a negative will result into a positive. So positive 1's about here. So this is 1. So it's about that point right here. Negative 2. It's negative 2. Right here. Plug it into the equation. Negative 1 times negative 2 is positive 2. Where's positive 2? It's about here. positive 2 and negative 2. There. So we have enough points to determine our line, correct? So the line always touches every point you write. Okay? That's one thing to remember. So that's about the line, give or take some. Okay? Now compare. When you're given the function y is equal to x, it goes this way at a constant rate. When you're given y is equal to negative x, it goes down at a constant rate. So if x is multiplied by a negative number, then as x increases, y decreases. So let's write that out. This is a key thing. So when x is multiplied by a negative, then the graph of the line will slope downwards. Okay? And when x, let me write it out here. Let's do it right here. Let's make a little more room. So when you're given x is when x is multiplied by a positive number, then the graph of the line will go up. Well, slope up, let me say. Slope up. See that? This is a basic algebra concept about graphing.